Have you ever known a fact, like you could recite it, but you didn't really get it? We've all been there, right? It's honestly one of the biggest challenges in education. How do we get students to go beyond just memorizing stuff and get to a place where they're connecting ideas and creating real deep meaning? Well, that is exactly what we're going to dive into. So think about it like this. On one side, you've got the old school goal, memorizing isolated facts. Flashcards, formulas, just recalling information. But on the other side, that's where the magic is. That's building genuine understanding. This is where students become active thinkers, piecing things together and constructing meaning for themselves. It's about shifting from just having a library of facts to building an interconnected web of knowledge. So how do we actually build that web? Well, the key is this powerful process called sense-making. You can think of it as the engine that drives students from just knowing what to truly understanding why and how. Now, when you look at this definition, there's one word that just jumps out: active. Sense-making isn't a passive thing that just happens to a student while they listen to a lecture. Oh no, it's something they do. They're in there interpreting, connecting, and explaining. It's the mental heavy lifting of building meaning for themselves. I love this quote from Peter Liljadal because it just nails the whole idea. It frames learning not as following some neat little recipe, but as that messy, authentic process of wrestling with a problem when you don't know the answer right away. It's about that productive struggle. That's where the real thinking happens. Okay, so theory is great, but how do we actually get students thinking this way? Let's get practical. I'm going to give you a starter toolkit, 3 high-impact strategies you can literally take and use in your classroom tomorrow. First up is notice and wonder. This one is so beautiful in its simplicity, but it is incredibly powerful for kicking off curiosity. What's great about it is that it gives every single student an entry point, no matter what they already know. The whole thing boils down to these 2 simple questions. First, what do you notice? This is an invitation for pure observation. There are no right or wrong answers, which takes all the pressure off. Then you follow up with, what do you wonder? And bam, you've just empowered students to ask their own questions, turning them into investigators from the get-go. So it all starts with some kind of stimulus, something intriguing, like this image here. It's pretty abstract, right? There's no obvious answer. So what do you notice? Maybe the sharp angles versus the clean, straight lines? And what do you wonder? Is it a mountain? Is it a logo for something? Those questions, the students' questions, they become the fuel for the rest of the lesson. And the process itself is super straightforward. You show them something interesting, give them a minute of quiet time to just look, and then you hit them at those 2 core questions. Now, the crucial part here is steps 4 and 5. You have to record every single idea without judgment. That creates a safe space. Then you actually use their wonderings to figure out where the lesson goes next. Their own curiosity is now driving the bus. All right, so we've sparked their curiosity. Now we need a way to help them organize and structure their thinking. That's where our second tool comes in: Claim, Evidence, Reasoning, or CER for short. This is a fantastic framework that helps students build strong, logical arguments instead of just sharing opinions. CER breaks it all down into 3 simple parts. Let's do a quick example. First, you've got the claim. That's just a 1-sentence answer to a question. Let's say our claim is, this plant needs sunlight to live. Simple enough. Okay, next up is evidence. This is the how do you know part. You got to bring the receipts, the data. So our evidence could be, the plant on the sunny windowsill grew 5 inches, but the identical plant in the dark closet wilted. Finally, and this is the most important piece, is the reasoning. This is the why. It's the logic or the scientific principle that connects your evidence back to your claim. So here, our reasoning would be, plants need sunlight to perform photosynthesis, which is how they create food to grow and survive. You see, it builds a complete, justified explanation. Our third strategy is all about making thinking visible. Concept mapping is such a cool way for students to untangle complex ideas, and, maybe more importantly, to actually see the relationships between them. So making a concept map is a pretty dynamic process. But the real magic, and I mean the real magic, happens in step 4. It's not just about drawing lines between bubbles. Students have to write linking phrases on those lines. Words like causes, leads to, or is an example of. This little step forces them to get super specific about the exact relationship between 2 ideas. And that's what reveals the true structure of their thinking. So, what happens when you actually start putting these strategies into play? It's way more than just a new classroom activity. It's a fundamental shift in the entire learning environment. It completely transforms the roles of both the teacher and the students. This table just lays out the transformation so perfectly. I mean, look at the shift. The teacher moves from being a dispenser of information to a facilitator of inquiry, asking questions, prompting. And in turn, the students, well, they go from being passive listeners to active sense makers. They're the ones connecting, justifying, revising their own ideas, and really thinking about how their understanding is growing. And the goal isn't just to do these things once in a while, it's to build towards real proficiency. As you can see on this rubric, the highest levels, applying and innovating, that's when students start using these sense-making moves all on their own. They start driving their own questions, testing their own ideas, and connecting what they're learning without always needing a prompt. That's when you go, it's really sticking. Okay, I know this can feel like a really big shift, but it absolutely doesn't have to happen all at once. The journey from memorization to true meaning starts with just one single intentional step. And that brings us to the most important question of all. What's your first step going to be? Think back to those 3 strategies we talked about: notice and wonder, claim evidence reasoning, or concept mapping. Which one of those sparks an idea for you? Which one could you try tomorrow to take just one lesson and shift it from a simple task of memorization to an invitation for real, deep sense-making